temperature, the microbial communities that are present, as well as feedstock composition. So sargassum seaweed, it's very rich in carbohydrates, and this makes it a very promising feedstock for biogas production. Rum distillery wastewater is high in organic matter, so it has a very high chemical oxygen demand, and this makes it very effective for the anaerobic digestion process as well. So sargassum seaweed has produced biogas on its own, but it has been found that co-digesting or combining substrates together to produce biogas is more efficient. And so I want to hypothesize here that the co-digestion of sargassum seaweed and rum distillery wastewater is a feasible method for efficient biomethane production. So now into the problem, as I mentioned before, sargassum seaweed has been plaguing our region. It's along the beaches, and we know that tourism is a thriving industry here in the Caribbean. However, the sargassum seaweed, beyond affecting the tourism sector, it has led to notable public health hazards. So for example, sargassum has recently been linked to a potential risk for preeclampsia, which is causing hypertension in ladies who are pregnant. And poor waste management leads to the discharge of rum distillery wastewater into marine environments. Rum distillery wastewater can also disrupt soil and aquatic ecosystems because of its high chemical oxygen demand. But like I mentioned before, this high chemical oxygen demand makes it efficient in the anaerobic digestion process. In terms of the methods that I used in the anaerobic digestion process for my experiments, they were biomethane measurements. So I measured the experiments over a 30-day period, took readings for them. I replicated the experiments using 10 replicates for each individual experiment. The temperature for each experiment was regulated between 35 to 38 degrees Celsius. The substrate to ratio composition volumes were quantitatively measured and recorded. And in terms of the qualitative methods to use for this study, they were observation and monitoring, so the process was very closely monitored for the performance of the anaerobic digesters on the different conditions, the inoculum selection, as well as the conditions management or assessment. I'll go now into my results. So here we can see biomethane production over the course of a 30-day period, and the formula that produced the most biomethane gas out had basically a 1-to-1 ratio of sargassum seaweed to the other components. However, the one that produced the least also had a similar volume, so there was no clear trend here, and I'll get a bit more into that later on in my presentation. In terms of co-digestion versus monodigestion, we can see the yellow bars show you the experiments that use co-digestion, and the blue bars show you the experiments that use monodigestion, and you can see that for the most part, these yellow bars outperform the blue bars. In terms of the substrate to inoculum ratios, we can see as well here that a 1-to-1 substrate to inoculum ratio produced the most biomethane gas out, and this is supported by the literature. And this result was very interesting. It was found that grass-fed cows produce more biomethane gas out in terms of being an inoculum than grain-fed cows. And I would say this is because of the diverse microbial communities that would be present in the guts of the cows that are grass-fed. And finally, looking at the substrate concentration, there also was no clear trend here. However, the sargassum volumes in each of the digesters were equal. So I would say that this shows that sargassum is a substrate that can assist with stability in terms of producing biogas out, because all of the experiments produced biogas once they were co-digested. So in terms of the implications of this study, I would say that the co-digestion of sargassum seaweed and rum distillery wastewater is a viable method for biomethane production. For the scalability potential, this shows promise for large-scale implementation in waste-to-energy solutions. And I definitely think there's a need for further analysis, such as physiochemical analysis and microbial testing, so that we can help to optimize the process, because there are various microbial organisms that we need to know about so that we can understand this process better. So in conclusion, I would say that the study definitely supports the hypothesis that co-digestion, which is combining sargassum seaweed and rum distillery wastewater, is more effective than the anaerobic digestion of a single substrate. The data suggests that grass-fed cows produce more biomethane than grain-fed cows, and this has implications for selecting the appropriate feedstocks to optimize biogas production. The research confirms that using sargassum seaweed and rum distillery waste for biomethane production is feasible. And finally, while the results here are promising, further testing such as physiochemical and microbial analysis are definitely necessary to optimize and scale the process for broader applications. And this is the end of my presentation. Thank you.
Okay, great job, Shamika. And you stayed perfectly on time. You have 1.5 minutes left. Now you could delve into more of your analysis. Just joking. All right, so now we come to that interesting point when I actually want to get some feedback from both discussants. We had 3 beautiful talks about sargassum. We had a nice talk on OTEC. We had a great talk on PCM, phase change materials in Jamaica. So I feel like we had a great inspiring session this morning. And I just want to get some general comments from Dr. Chadee first, and then I'll ask Dr. Felix to give some general overview comments before we jump into that Q&A, in which I just want to remind the audience and remind the participants that the students are being assessed, and part of it is their ability to engage in that back and forth conversation. They're also being assessed on that. So, which is why we beg for your questions. We would love to see some questions coming in the webinar chat. But first, I just want to get some feedback from Dr. Chadee, all her experience as an MSc coordinator in the renewable energy space, and then from Dr. Felix.
Okay, thanks a lot, Dr. Henry. First, I would like to commend all of these postgraduate students here for their wonderful presentations. I was very much impressed by the fact that you all are trying to solve problems very much relevant to the Caribbean region. And from the three sargassum projects, I mean, it's quite clear that you all are trying to take a product, well, a commodity that is a nuisance, and trying to create higher value commodities. So this is excellent. And, as a Trini, I appreciate that, because, in Trinidad here, we take our oil and gas to produce higher value products such as methane and ammonia, which we export. So everything that you all are doing here now means that you all are trying to create products that will bring in more income now to the Caribbean region. And also with the OTEC projects, I mean, we saw one that, tried to use thermoelectric material instead of a working fluid, and that is also very much innovative, because OTEC is one of those renewable energy technologies that are not widely used around the world. And yes, we know the tropical region is where we could really use it, and it's excellent to see that there's a different approach that is trying to improve the efficiency in OTEC technologies. Also, the other project here on buildings and cooling buildings. Again, a very much critical problem where we have global warming increasing the temperatures around the world. And while in the Caribbean, we are trying to adapt to climate change impacts by strengthening our building infrastructure. I really liked how the presenter highlighted another core problem, which is that, yes, we need to adapt, but we also need to consider the thermal comfort of people in buildings in the future. So again, I must say, all of these presentations really highlight core problems that require a solution. And it is this this looking at the applied physics and applied chemistry solutions here, which would really help with getting some funding too. So I hope, you know, alongside with your supervisors, that you'll really try to see how to get some funding to get your projects to hopefully in some form of commercial stage, if possible, right? Now, let me just check my notes here and see if I have anything additional to say along those lines. Okay, so those are my main broad comments, and I will ask Dr. Felix to give her broad comments before I get into some of the questions. And also I see attendees have their hand up as well.
Okay.
Right, and also there's a Q&A session, and I saw an anonymous attendee put a question in there. So folks can start putting questions in. If the chat is too crowded, it's actually easier for us to see the questions in the actual Q&A tab. So please, I encourage to keep dropping them in there. And Dr. Felix, sorry, go ahead.
Okay, thank you very much. I share the same sentiments with Dr. Chadee. Actually, the presentations were well done. They were very, very good presentations. I was quite impressed with the work that is done. More impressed with the point that, you know, now COP29 is going on, and we are all about transitioning from oil and gas, fossil fuels into renewable energy. And to see these projects come up and within a Caribbean setting was very reassuring, and I was really quite impressed. And as Dr. Chadee said, being a Trinity too, where we hold on, where fossil fuels really drive our economy, and yet still we know the disadvantage it does to the environment. When we hear and we see of alternative research progressing like this, it's really reassuring that, okay, we can probably fix, you know, our oil and gas situation, and we can move into renewable energy in an effort to protect our environment. And that is what our key issue is here, to protect the environment. And in all these presentations today, I can see an effort to protect some part of the environment. So I was quite impressed with the work that was done. And yeah, I look forward to asking my questions and listening to other comments. But that's my general comment. Very good presentations.
Okay, great. That's encouraging. And like I said, the theme is optimistic, one of optimism. I forgot about COP29, I think it is, going on right now.
Right,
So
now.
for that reminder,
Yes.
Dr. Felix.
Azerbaijan. Yes.
Yeah, that we could sit here with these students, these innovators who are Caribbean based, and see Caribbean innovators solving questions of climate using the resources we have. And take note, and I mean, somebody mentioned the sargassum starting in West Africa and coming across the Atlantic. And the fact is, some of these issues are global. A PCM is a global question, and the presenter, he showed different parts of the world and where the comfort levels are, etc. And so these questions we're asking are global in the implications, the solutions. And I echo Dr. Chadee when she said, let's start even thinking about moving these things from lab to pilot, looking at ways to find funding, because there's lots of opportunities to fund these kinds of projects. So I agree. So I'm gonna ask Dr. Chadee now. So we're here until 12:15, and I mean, we don't have to take up the whole space, but that's an opportunity. We have a 30-minute discussion, back and forth questions with the presenters. I'll start lining up some of the ones from the audience, but I would like to hear the discussants ask specific questions to each of the presenters, and we'll start with Dr. Chadee. So I think we could spend the next 10 minutes or so just kind of having both discussants examine the students, and then we'll jump to questions that are coming in from our audience. Thank you.
Okay, thanks, Dr. Henry. I do have to jump off by 12, right? Okay, so for Lenica, first I saw one of the questions in the chat, and this is actually a question I had, right? What prompted the use of PCMs to be considered for use from the